We're all living in this IoT age now, aren't we?
Hmm.
Smart watches, smart homes, even smart cars. It
Yeah,
feels like everything's connected.
it really does. Everything seems to just work.
Right. But behind that smooth experience, well, there's this whole hidden world, isn't there? A massive amount of complexity making sure these things are reliable and maybe more importantly, secure.
Absolutely.
And that's exactly what we're digging into today in this deep dive. The whole world of IoT testing. We've got some great source material you provided, and our mission really is to peel back those layers,
Hmm.
to understand why testing these devices isn't just, nice to have, it's absolutely critical
Yeah,
for safety, for our data, for everything.
exactly. We're going to try and unlock that unseen work, go beyond just the buzzwords, and really unpack what IoT testing involves.
Okay.
We'll look at, the different parts, the challenges, the kinds of tests, even the tools they use. The idea is you walk away really getting how QA makes this whole connected world function properly and safely.
Okay, let's unpack this then. Maybe let's start right at the basics, just for anyone who might not be completely clear. What exactly is the Internet of Things, fundamentally?
That's a good starting point because I think people get the connected part, but maybe not the scale or the implications.
Mm.
Fundamentally, IoT is this huge network. Devices, vehicles, buildings, really any electronic thing fitted with sensors and software that can connect and exchange data.
So it's more than just my phone talking to my speaker.
Oh, way more. It's this era of smart, connected products, constantly talking, sending enormous amounts of data, usually up to the cloud. It's really about identifiable, embedded devices hooked into the existing internet. But the scale, like you said, is just unprecedented.
And these systems, they have common parts, right? Our sources mentioned that.
Yes, typically you see four main components working together. First, you've got the sensor. That's the thing collecting the raw data, like a thermostat sensing room temperature, or maybe a camera seeing motion. Yes. Then there's the application. That's often what you interact with the app on your phone showing the temperature or the interface that lets you see the camera feed. It processes and presents the data.
Makes sense.
Next up is the network. This is crucial. It's the communication path. Wi-Fi, cellular, Bluetooth, whatever it is that lets the sensor talk to the application and the back end.
Right, the connection itself.
Exactly. And finally, the back end. Think of this as the brain or the central hub. It's usually cloud servers, data centers, where all that data gets stored, analyzed, processed. It makes sense of everything the sensors are collecting.
Okay. So you've got these four distinct parts. That already sounds like, well, like a lot of places, things could potentially go wrong.
Precisely.
Mm-hmm.
Imagine a faulty sensor sending bad data. That could mess up the application's logic, clog the network, fill the back end with junk. It's a potential cascade effect.
Which leads us right back to testing, because every single one of these devices is sending and receiving data, often sensitive stuff, wirelessly. Testing becomes, well, non-negotiable, doesn't it?
It's absolutely non-negotiable.
Yeah.
IoT testing is all about running specific QA tests across all those components, sensor, app, network, backend, before anything hits the market.
Right.
The main goal is just to make sure devices meet their requirements. They work like they're supposed to, reliably and securely. And because it's so complex, you see a lot of reliance on automation, performance testing tools, and something called penetration testing.
Penetration testing.
Yeah, it's basically ethical hacking. You try to break into your own system to find vulnerabilities before malicious actors do. It's essential for IoT security.
Okay, so we know why testing is so vital, but what does that testing actually look like? Our sources mentioned it's not just one type of test, right? It covers a whole spectrum.
That's right. It's definitely not one size fits all.
Right.
Broadly, you're testing things like security, how the analytics work, the device hardware and software itself, the networks, processors, operating systems, the platforms they run on, even if they meet industry standards.
Yeah.
But digging deeper, there are specific types of testing that are really key in the IoT world. For instance, usability testing.
How easy it is to use.
Exactly. But think about the variety. A tiny wearable, a smart fridge screen, a voice assistant. They all need to be intuitive, despite wildly different forms. And user expectations vary too, so you need to make sure it's easy for everyone.
Good point. What else?
Compatibility testing is another big one. You have countless devices, different software versions, different hardware from potentially hundreds of manufacturers.
Making sure my smart bulb talks to my smart plug, even if they're different brands.
Precisely. The number of possible combinations is just staggering. Testing that they all play nice together is crucial.
Okay.
Then security testing. We touched on this, but it's worth stressing. These devices can be gateways into our networks. Many users won't be accessing data, so validating users' authentication, data privacy controls, it's absolutely critical.
You really can't overstate that one.
You really can't. And then there's performance testing. You need these devices to be responsive. Imagine a laggy smart security camera feed during a break-in. Not good. So testing under various conditions, under load, is essential.
So different tests for different needs, but what really struck me from the sources was how these different tests apply to different parts of that IoT system we talked about. The sensor, application, network, backend. It's not just random, there's a logic to it.
Yes, that's a fascinating insight. It's like having a map showing where to focus your testing efforts. It really highlights the specific vulnerabilities of each layer.
So how does that break down?
Well, think about security testing. As we said, it's critical everywhere. So it applies across the board: sensor, application, network, and backend. A security hole anywhere can compromise the whole thing.
Okay, that makes sense. It's the foundation.
Exactly. But then you take something like functional testing or usability testing or compatibility. These mostly apply to the sensor and the application.
Right, the bits the user interacts with or that gather the initial data.
Precisely. You wouldn't really do a usability test on the back-end data center itself.
Uh-huh, probably not.
And then you have things like performance testing and services testing.
Mhm.
These are critical for the application, the network, and the back end. How fast data moves, how the cloud handles requests, but generally not for the sensor itself in isolation.
Interesting. So the sensor's individual performance isn't the focus there. It's more about the system's overkill performance once the data leaves the sensor.
Exactly. That distinction is really important. It shows you need tailored strategies. You can't just throw the same tests at every component. It forces a much more specialized approach to QA.
Okay, so that's the strategic map. Now let's get into the nitty-gritty. What does this mean for the person actually doing the testing day to day? Our sources gave some really concrete examples of test conditions.
They did. And it gets very detailed. For instance, under components validation, testers are looking at the actual physical hardware, the embedded software running on the device, the cloud infrastructure it connects to, network connectivity itself, even third-party software integrations, making sure all those pieces work together.
Wow, down to the chip level almost.
Pretty much. Then for sensor testing, you're really focusing on that initial data capture. Is it responding to commands correctly? That's command testing. Is the data it sends formatted right? Data format testing. Can it handle weird conditions or errors? That's robustness testing.
Okay.
Function validation is about the basics. Does the device do what it's supposed to? Can it talk to other IoT devices? How does it handle errors, like if the network drops? Does it perform calculations correctly?
The core job, essentially.
Right. And performance validation digs into specifics, like how often does it send data? Can it handle lots of requests at once? How well does the device itself perform under stress? Synchronization, interrupt testing, things like that.
And security again, I assume.
Oh, absolutely. Security and data validation is huge.
Yeah.
Are the data packets valid? Is anything getting lost or corrupted? Critically, is the data encrypted properly? Are user roles enforced? Can user A see user B's data?
Vital stuff?
Then you've got gateway validation, testing that bridge between the device and the cloud. Checking the interface, the protocols, looking for delays or latency.
Making sure the message gets through cleanly.
Exactly. And finally, analytics validation. All this data is often used to generate insights. So are those analytics accurate? Are the system filters working? Are the automation rules firing correctly?
That is incredibly thorough. It really paints a picture of the complexity.
It is. And that complexity leads directly to the challenges.
Yeah, that was my next thought. With all these layers and interactions, what are the biggest hurdles testers face in the IoT space? It sounds like a minefield.
It definitely has its unique challenges. One big one is checking both network communication and the internal communication within the device itself. They often use different protocols, different mechanisms, and both have to work seamlessly.
Okay, 2 layers of communication to worry about.
Right. And security, as you keep saying, is just a massive concern. Everything's online, making every single device a potential entry point for attackers. It's a much wider, more distributed attack surface than traditional IT systems.
Makes sense.
Then there's the sheer complexity of the software and the whole system. So many moving parts, interactions, data streams. It's just inherently easy for bugs to hide in the cracks. They can be really hard to find and even harder to reproduce consistently.
Like chasing ghosts sometimes, I bet.
If you like that. And finally, resource constraints. This is a big one for IoT. Unlike your laptop or a server, these devices often have very limited memory, processing power, network bandwidth, and especially battery life.
Ah, right. You can't just run a huge test suite if it drains the battery in 10 minutes.
Exactly. Testers have to work within those limits. A smart sensor that runs out of power isn't very smart. It can mean lost data or failure in a critical situation, like a medical monitor.
Okay, so the challenges are significant, but presumably there are ways to tackle them. Our sources mention some best practices.
Yes, absolutely. Experts have developed strategies. One really valuable approach mentioned is gray box testing.
Gray box.
Yeah, it's sort of a middle ground. Not black box where you know nothing about the insides, and not white box where you know everything.
Hmm.
With gray box, the tester has some knowledge, maybe the basic architecture, the OS, known hardware limits.
How does that help?
It lets them design much smarter, more effective test cases. They understand potential weaknesses or limitations based on that partial knowledge. It's very efficient for finding certain types of bugs in complex systems like IoT.
Okay, using partial knowledge to test smarter. What else?
Using real-time operating systems, or RTOS, is often vital. These aren't like Windows or Mac OS. They're super lightweight, designed for immediate response. Think mission-critical stuff like industrial controls or medical devices.
They need to react instantly.
Precisely. RTOS helps deliver that scalability, reliability, and security needed for many IoT applications. It's about ensuring the device does the right thing right now.
Makes sense.
And a fundamental point that came through in the sources. IoT testing really needs to be automated as much as humanly possible.
Just because of the scale?
Scale, complexity, the sheer number of interactions and states. Manual testing just can't cover it all consistently or quickly enough. Automation brings speed, repeatability, and broader coverage.
Okay. And are there specific tools people use to help with all this? The sources mentioned a couple.
They did. Two interesting ones highlighted were Shodan and Thingful.
Shodan, what's that?
Shodan is often called a search engine for the Internet of Things. It basically scans the internet looking for connected devices, servers, webcams, routers, industrial controls, you name it.
So you can see what's exposed online.
Exactly. You can use it to find your own devices that might be unintentionally exposed online. It helps track what's accessible, what services are running, crucial for security audits.
Wow, okay.
Yeah.
And Thingful.
Thingful is also described as an IoT search engine, but it seems more focused on enabling secure interoperability, helping different devices and data streams work together securely and giving users control over how that data is used. It aims to help make sense of all the data flowing from millions of devices.
Helping manage the data flood, essentially.
Sort of, yeah.
Yeah.
Making it more usable and valuable.
This has been really insightful. So, quick recap. IoT connects all these identifiable embedded devices to the internet, creating huge complexity. And that complexity means bugs can easily hide, making testing absolutely essential across all those components: sensors, apps, networks, backend.
Right.
And approaches like gray box testing, using RTOS, and heavy automation are key strategies for tackling this effectively.
That covers the core idea as well. And the end goal of all this, remember, is for the user. It's about ensuring an improved, reliable, and crucially secure experience with all these connected devices that are becoming part of our lives.
Definitely. And one final thought that stuck with me from the sources. They made it clear that if you don't have a really comprehensive test plan, some issues, some properties of the system simply can't be measured or verified.
Which means bugs can slip through.
Exactly. Errors or bugs might just go completely undetected. So next time you interact with your smart thermostat or rely on a connected medical device, maybe take a second to think about that invisible, incredibly complex dance of testing happening behind the scenes and what might happen if a step in that dance gets missed. It really underpins so much of the smart world around us.